Okay, welcome to today's session. So today we're just gonna be uh, doing an introduction to classes. So by the end of this session, you should be able to define a class and declare, some objects of that class, constructors, getters and setters. So yeah, but then we're gonna start by doing what's this, a revision of record structures. So let me go ahead and create my project. So yeah, we're still going to use modular programming. So session one. So at this part, I don't need to explain a lot. So we have our source folder, docs folder. What else? Bin folder. Let me create my bash file. Build .bat. So yeah, I'm just gonna be today. I'm just gonna be going slow because I think there's a lot of time, and what we're doing doesn't really take up that much of time. So just be going slow. Mm, 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 I'm gonna create my main.cpp, my source files, main.cpp. Then let's have, what can I name this? Let me name this. No. Let me name this UJ module. Let me name it student.cpp. Okay. I hope you remember how to compile, how to write your batch file. Get echo of then to compile our code, we use G++. Then we specify the standard, which is C++20. I think right now we're at C++23 or something, but let's just use C++20. Then since we're going to be using modular programming, so we have to specify, we have to write this command dash f modules, we'll see dash ts, then specify the source files that we're going to compile. So we have student.cpp, which is in our source folder, student.cpp. Then we also have our main.cpp, also located in our source folder, main.cpp. Then at the end, we have to create our executable. This is how. So we're going to store our executable in our bin folder. So I'm just going to name my executable build.exe. And to run our program, so we're just going to run our executable. So build, so it's in the bin folder. So this is going to be build. No, this is supposed to be like what slashes. Let me keep those as forward slashes. I'll change them if it gives me an error. Then pause. In my student.cpp, let's create our module. So it's gonna be module, and then I'm gonna include my libraries, IOStream, declare my module. So we have export module, the name of the module, let's call it UJ module, UJ. Let's just call it student module, student module. Then can say using namespace std. Then let's define our namespace. Namespace, let's call it student space. Student space. You'll probably be using, but it's fine. So I'm gonna just create my export scope over here. So let's just write one function, display function. See how display void display. I just have actually before every session I must just with this thing pre-coded because this is a waste of time. We already know this stuff. Next time. Then here let me include hashtag include IO stream. Import my module. So we have student module. And using namespace std, using namespace student space. Let's create our main function int main. And just gonna change 0 at the end. So let's just call our display function. Display. Then I'm just gonna compile this and make sure everything is done everything correctly. No. Okay, let me check what's going on. So F modules, TS, CRC, SRC, student.cpp, SRC main.cpp. That's correct. Let's try to compile this thing again. I don't know what's the problem. Let me write those things as backslashes. You know, change this thing to backslashes. And then we forgot a dash over here. So this is dash standard is equals to C++20. Yeah. Okay, yeah, then that should be fine. Hello, Brandon. Okay. Okay, let's start. So we're just gonna first do record structures, just for revision. So remember, a record structure is it's like it's a collection of data. So So the official definition is it's a user-defined data type that groups related variables of different data types under one name. So basically, we're creating our own data type, but then by grouping related data in the same data type. So for today's example, so let's just create our record structure. Struct. Let's create a student record structure. Student. Mm, okay, so we're just gonna add some few things. So let's have. Mm, can we have? Let's store the student name. And the student's course and the student's age. Okay, now that's fine. So I'm just gonna add a function to set up a student. So let me just create a void function. I'm gonna call it create student. So we're gonna pass a student by reference student, and we're going to pass in the name. And just say n is for the name. Then we're gonna pass as the course, and just write it as C. Then we're gonna pass in the age, and we just write it as with the letter A. Okay. So in here, we're just gonna set up our record structure. So we're gonna say student dot name scores to n, and student dot course course scores to C, then student dot age scores to capital letter A. Okay, yeah, then that's fine. So this is our record structure. We just defined our record structure over here, and we're gonna use this function to create our record structure student. So let me just, so for this function, so let's change this function, this display function, and let's pass in a record structure student, and let us display the details of that record structure. So cout student details and line, and cout. Let's have name, then let us display the name student dot name, and cout the course. Hope this is how we write course. Student dot course. Then cout age student dot age. Okay, so let's use those. So in our main.cpp, so let's create a student. So student, and let's call him student1. Then to create our student, so at the moment our student, so if we say display, if we display our student details using our function display, so we're gonna pass our student. So at the moment, our student details are just initials to some random values. So this is just some random values. So we're gonna use our function to create our record structure. Just to initialize, the the details of our student. So I'm gonna use this function, grade student. Grade student. So I'm gonna pass our student. Then I'm gonna pass the name of the student. Let's name our student letter O, for example. Then she's doing BSc in, I don't know how you write it, actual science, whatever, however you write it, actual science. She's probably 19, maybe not. So create student. So if we run our code now, the student details should be those we just passed. Yeah. Yeah. So yeah, this is the record structure. So the thing with record structures, there's one, like there's a disadvantage of using record structures. So with record structures, you can only group data, as in like variables. You can only group variables into in a record structure. But then what if you also want to add functions? So with record structures, this is not possible. It's not possible that our record structure can have maybe like a function inside. This is not possible. So, but then the easy way we can trick our record structure into thinking that it's only storing data using what we call function pointers. So what a function pointer is that it's a variable that stores the memory address of a function, so allowing the function to be called indirectly. So in our record structure, you can just have a data. You can just have a data, and maybe let's call it display. You can just have a data like this. So in order to make it a function pointer, okay, let me open up my notes. So yeah, but then yeah, anyway, in our record structure, so we can have like some sort of data, a function pointer. So that function pointer, we're gonna make it point to a function. So our record structure is gonna think that it only contains data inside of it, but then that data is going to point to a function because record structures can't store functions. So we're gonna use uh, that function pointer. So how do we declare function pointers? So to declare a function pointer, so let me write something here. So to declare a function pointer, we write the return type. So we're gonna write the return type. Then in an open and close round brackets, open and close round brackets. So in the first round brackets, we're gonna make a pointer. Then we write the name of the function. So name of function. Then in our second round brackets, we're going to insert our parameters. So let's say our function has parameters, just like this, for example. So this is where we're going to pass those parameters. So let's say, for example, int A and int B. So this is how we declare a function pointer. So for example, we're gonna create a function pointer and call it display. Then we're going to make it point to this function. So we should probably not name it the same as this, but I think it's possible. So let's try it. So our return type is going to be void. Then we're gonna open and close around brackets pointer. So let's name our function display. Then let's pass our parameters. So for parameters, we're just gonna pass a student by reference. Just like this. Okay. Then this is our function pointer. So now at the moment, our function pointer does not point to any function. So in our function to create our student, this is where we're going to make it point to a function. So how do we do that? So here we just come here and say student. So we access this function pointer as normal as how we will access all the other data in our constructor. So this is going to be student dot display. Then we're just going to say this is equals to a function. So at the moment, this is our function. So we're just going to say this is equals to a function, our function display, just like that. So now our display stores um, so our function like points to now our function pointer points to this function display, and this is the implementation of the function over here. So I don't think it's a problem if you name the function pointer the same as your function which you want it to point to. I don't think it's a problem. So yeah, so our function pointer stores the memory address of this function. So now let's see how do we use it. So let's cancel this. So yeah, so this is how we're going to call our function pointer. So we're gonna say student1 dot display. Then we're going to pass in our arguments. So at the moment, our display function must accept a student. So we're gonna pass student1. Okay. Then yeah, then we're going to run this, check if everything is correct. Okay. Oh, damn it. Yeah, let's run and compile. It's taking forever. Yeah. So as you can see now, our record structure kind of has a function, but then it's not really a function. It's just a function pointer pointing to a function. So it's not possible for us to have functions in record structures, but then in order, if we really want functions in our record structures, we can use these function pointers. So any question on that before we move on? Maybe here. Any question on that? Is that clear? All right. So yeah. So now C++. So so imagine if we wanted a record structure with so many functions in it. So we can like be so function pointers take up memory first of all. So that's kind of a disadvantage. So we can't really rely on record structure. So let's say we want data that can store data and functions that works on those data. So C++ has given us something else called classes. So now this is where we're getting into object-oriented programming. So which I don't really normally teach theory, but then object orientation oriented programming is programming a paradigm that organizes programs using objects, which combines data and functions and operates on that data. So, with OOP, object-oriented programming, so we can have data, we can have like a data type, and that data type, we can have it to store uh, variables, and we can make it, we can be able to store functions that do something on those variables. So this is how we're going to go to classes. So what is a class? So a class is like basically the opposite of a structure. So with a structure, we can only store data, but then with a class, we can store both data and functions. So in with classes, we don't need to create function pointers. So a class is, so we can define a class. You know how we define a structure. This is like a blueprint. Then afterwards, so this thing becomes like a data type. Then afterward, we declare a variable of that data type. So what a class is? A class is a blueprint or template used to create objects. So it defines the data, which is a attributes, and the functions an object will have. So going to go to classes. So for example, um, yeah, let's just continue with a class called student. Just for so I'm gonna comment this out. Just gonna leave them here and comment them out. So now how do we create a class? So we say class, then we write the name of a class. So our class, we're gonna have a student class. So same as record structures, there's a semicolon in the on the after the last curly braces. There's a semicolon, just like how you do it with record structures. So so in our class, uh, remember I said we can have variables. So for variables, I'm just gonna say data. So variables, I'm just gonna say data, and we can also have methods, those are functions. So these methods are going to work on our variables. So you know how these things in our record structure are public, and we can just access them anywhere. So same as our classes. So in our classes, there are two different ways which we can access our data. So we call those access specifiers. So in our in our classes, we have three. We should have three access specifiers. So access specifier determines the visibility and accessibility of the members of a class. So these things we just call them members of a class. So the variables and the methods in belonging to our class, we just call them members of our class. So now we're gonna firstly create an example using uh, the public access specifier. So this is what we're gonna do. So if you want your data to be public, to be able to access that data outside your class, you have to declare them as public. So let me do this. I think I can remove this. So let me add this protected. So yeah, we have these three access specifiers. So it's either you can declare your data as public, or you can declare your data as private, or you can declare your data as protected. So if you are declaring your data as public, it means you can access those data outside your class. Then if you declaring data as private, it means you can only access those data only within your class. And protected, okay, protected, we're not going to go through protected now, so we're going to learn about it later on in our sessions. So now, so for our public data, so let's have a string, let's have a string name, and let's have course, let's have a course, then let's have age, so int age. So yeah, at the moment, this is what we have. Then we add, can also add a function. So let's say we want to add a function to display the information of our student. We can add it here. So I'm going to make it a void function. So void display, then we're not going to pass anything. So to display our thing, let me copy out this. Let me do that. So now since this data is public, so it means we are able to access our data outside the class and inside the class. So here, what we're gonna do, we're just gonna call our data. We're just gonna say name because we're within our class. So just gonna say name, and here we're just gonna say course, and here we're just gonna display age, just like that. Okay. So yeah, now this is our class. So now, so class is like it's like a data type, but then we don't really call it data type. It's like, but it's like a data type. So now, let's say we want to create a variable of our data type class. So we call this object. So if we're declaring an instance of our class, we call it an object. So an object is an instance of our class. So this is how we do it. Same as how we would do it with a record structure. So this is our object student, a student one of type student. So now let's say, so let's call this function display. So this is how we will call it. Let's just call display and display the information of our student. So at the moment, we haven't really initialized everything. So the details of our student are just randomized, are just initialized to some random values. So as you can see, these are just randomized to some random values. So now, but then we can do this. So since our data is public, we're able to access these things outside. So we can actually access our data and initialize them outside our class. So let's say we want to set the student name, initialize the student name to something. So let's say this is our student name. Let's set it to a letter O. Then let's set our course. Then let's set our course to maybe something like ESC and IT. Then let's set the age to something like, let's say 26, for example. So now if we run our code, so our data at the moment is public, so we're allowed to do this. So if we run our code now, our function display is going to display all of these details here. So let me Let's compile and run our code and see what happens. So yeah, as you can see, as we have our information displayed there. So let's say uh, we remove this data under the public access and we declare, let's say we declare them as private and not as public. What's going to happen? And we try to do this. Remember, if you are declaring data as private, you can only access that data and call it within your class. You cannot call it outside your class. So this is illegal. So you can see if I try to run this is going to give me an error. As you can see, so it's not possible for us, if something is declared as private, it's not possible for us to access it outside our class. So we cannot do this. So unless if these were declared as public, so let me remove them and put them back. Unless if they were declared as public, we can be able to actually access this data outside of our class. So if I compile that again, we see our program will execute on fine. So as you can see. So yeah, any question on what you just did? So normally we have to, so any question before I carry on, any question on classes so far? So here we just define our class and we declared our object this side. And yeah, any question? I see you just joined. Okay. Okay, let's move on. So now we're going to declare our data as private. So we're going to declare our data as private. So if we declare our data as private, it means we're not going to be able to access this data outside of our class. So if we can access those data outside of our class, so now how do we access this data? So to access this data, we're going to use what we call setters and getters. So setters and getters are actually functions we use to be able to access and modify this data. So each variable, let's say name. So the variable name is going to have its own setter and it's going to have its own getter. Then course is going to have its own setter and it's going to have its own getter. So setters and getters. So let's declare them here so we can see them. So setters and getters. So we use setters to initialize or set to modify this data, and we use getters to retrieve this data. So since in here we can be able to do this, so we're gonna have to declare those setters and getters. So let's say we want to be able to access our name. So what we're gonna do, let's start by creating a setter. So a setter is just used to modify the data. So we can make it a void function. So let's say set name. Then here we're gonna pass in a name. So let me just say string n. Then what we're gonna do here is that we're gonna modify our name. So we're just gonna say name is equals to n. So setters are just used, we just use them to modify our data. So these are a setter for our name. So let's also create setters for course and age. So void set course. Then we're gonna pass in our cost. Let's just say C. So here we're just gonna say cost is cost to C. Then void set age. Then we're gonna pass in our age. Let me just say A. Then we're gonna set our age to A. So now when we come to our main.cpp, so we obviously can't do this. But then what if we want to set our name and cost and age? So now we're going to instead use our setters. We're going to instead use our setters to set our variables. So this is how we call our setters. So same way we access any data, we use the dot operator. So we're gonna call the set name function. So I'm gonna say set name, then we pass in a name. So just gonna pass in, for this example, let's pass Brandon. I don't know who's Brandon. Then for the cost, so we can set our cost like that because it's private. So we're gonna use our setter. So we're gonna say set cost, then we pass in our cost. So let's say this guy is doing BSc in comsci and informatics. Okay, then for the age as well, we're gonna do that. So set age, we're gonna call our function, our setter, call set age, then pass in our age. Maybe this guy is 21. And yeah, so if we call our display function, our data should be set. As you can see. So yeah, so if data is private and we want to modify our data, if it's private, you can't access it outside our class. So to be able to access it outside our class, we introduce getters and setters. So setters are the one we use to modify our data. So now let's say we want to display name. So obviously our name is private. We can't do this. We can't say student dot name. This is not possible. This is gonna give us an error. Why? Because our name is private. So if I try to run that, this is going to give me an error. So now, how do we fix that? So this is where getters come in. So getters are just used to get our data. So here, so each data has its own getter. So same as each data has its own setter. So now with getters, so if our data is of data type string, it means our getter must return a string. So remember, with getters we return something. Then with setters we just set something. We just set our data. With getters we return our data. So we're gonna call our getter get name. We're gonna call it get name. So we don't pass anything. So in our setter we just return our data. So this is a get name. This is a getter for our name. So we're just gonna return name. Then yeah, we're gonna create the getters for the rest of our data. So we have our cost. So our cost is a string. So it means our return type here must be a string. And we're gonna call it set get cost. We don't pass anything. Then we're going to just return our cost. Then we're also gonna have a getter for our age. So our age is an integer, so it means our return type for our getter is supposed to be an integer. So we're gonna call it get age. don't pass anything, and we're just gonna return our age. So now, if we wanted to to display maybe our name without using this display function, let's say that display function did not exist, but then we wanted to have access to our name. This is how we're gonna do it. We're going to call our getter. So we're just gonna say get name. Sorry, get name. This is how we will do it. Let me return the rest. So let's also return the course using its getter as get course. Then we also have get age. So now if we run this program, yeah, as you can see, so we use our getters to be able to access our data. So this is how we use getters and setters. So if our data is private, so and we want to access it our outside our class, so we can access the data indirectly by using setters and getters. So these are our setters and getters. So any question? So yeah, setters and getters are also called accessors and modifiers. So a getter is an accessor. So accessor, then a setter. A setter is a modifier. No, it's actually a mutator. Mutator. It's a mutator function. So setters are called mutator functions because we use them to modify our data. Then getters are called accessor functions because we use them to access our data. Just like this, we use them to access our data. Then setters, we call them mutators because we use them to modify our data. So yeah. Uh okay, let's now go to Kevin is actually carrying here. Oh, so let's actually so now let's go on to what's known as constructors. So the definition of a constructor is a special member function that is automatically called when an object is created. So its purpose is to initialize the object's data. So a constructor is a special member function. It's a function that is automatically called when an object is created. So its purpose is to initialize the object's data. So at the moment, this is how we create our object. So at the moment, there is a, a constructor is called here. That constructor is called the default constructor. Obviously, you can see it now. So so let's say so let's remove this. Let's remove this and let's just display. So obviously, if we create our if we just create our object and not initialize our values, obviously they will be initialized to some random values. Automatically they'll be initialized to some random values. Hey, motherfucker. Part of this app has been blocked. So yeah, as you can see, this will be initialized to some random values, some to spaces. So uh let's say like when I create my object, I want my object, let's say I want my object to be automatically my data in my object to be automatically initialized to something. So if I want that to happen, if I don't want my data to be initialized to some random values, um I have to we have to use what's called constructors. So constructors are called automatically when you create your object, and we use them to initialize our data. So how do we create those special functions? So this is how we do it. So constructors don't have a return type, and the name of our constructors. So we usually have 4 different constructors. So we firstly have the default constructor. So if you don't declare any a constructor at all, a default constructor is like it's always gonna be there. So at the moment, what we're doing here, we're calling the default constructor. Even if you don't declare a default constructor, a default constructor is always going to be there, even if you don't declare it. So a default constructor is a constructor without parameters. I can say that. So a default constructor, it's called if you don't have any other constructor. So that's what the default constructor is. Then we have we also have our second constructor. It's called a constructor with parameters. Parameterized. It's called a parameterized constructor. Parameterized constructor is a constructor with parameters. So let's just say para. I don't know if this will be the correct spelling. Parameterized constructor. So a parameterized constructor is a constructor with parameters. Then also have a copy constructor. So I'll explain what they do just now. Copy constructor. Then we're gonna have a, what's that? What's that for? Deconstructor. So finally we have a deconstructor. So with a default constructor, so this is how we declare constructor. So the constructor doesn't have a return type, and the name of the constructor is the same as the name of our class. So meaning, so this is how we declare our default constructor. So with our default constructor, we don't pass anything in our as parameters. This is just our default constructor. So as I said, constructors are special functions which are called automatically when you create your object to initialize your data. So in the default constructor, we're just going to use it to initialize our data to something, so that when we run our thingy without. So you see, if we don't initialize our data, so our data is just going to be initialized to some random values, but then we don't want our data to be initialized to some random values. That's why we use what's known as a constructor. So for a constructor, we're just gonna initialize our data to some default values. So if any case we don't initialize our data, so our data is going to be initialized to these default values, which we're gonna specify here in our default constructor. So for our name, the default name, uh, let's say our default name is student. Yeah, let's just call it student. Yeah, not very ideal. Then for the course, uh, then for the course, our default course, let's say, yeah, if everybody, so every student before, maybe every student is obviously going to be enrolled automatically in the orientation course. So let's just say this orientation is it's a course. Let me say ESC. This is unnecessary. Let me just say orientation. Then here, let me just say student. Then the student age, let's just initialize it to let's just assume it's 19. So remember I said this construct. So how do we call this constructor? So this constructor, the default constructor, is called automatically. So now, so if I run my program now, so the default constructor, as I said, if you don't define it, it's always gonna be there, but then there's nothing's going to be initialized. The data is just gonna be initialized to some random values. So you have to define it on your own so you can so that you can initialize your data to your liking. So now if we run this now, so when we create our object, our default constructor is going to be called automatically. And what happened in our default constructor is that our data is initialized to these values. So now if now we run this, if we compile and run this, we're gonna see that our student is going to have our initial, it's gonna be initialized to this I don't know what to say. So our student um so our student as data is going to be initialized to whatever we defined in our default constructor. So this is the purpose of a default constructor. So this is for like in a case where we don't define values for data. So if we don't define values for data, at least our default constructor is going to initialize those data to some values. So this is the purpose of our default constructor. So any question? Any question? On default constructors. Okay. So now let's move on to parameterized constructors. So as I said, parameterized constructors, those are constructors with parameters. I don't know why I didn't finish this. Constructor with parameters. So as I said, a constructor doesn't have a return type, and a constructor is the same, is the constructor's name is the name of their class. So we're just gonna say student. But then this is for a parameterized constructor, we pass in something. So this is just a constructor. This is the same thing, but then the difference that this one is going to have parameters inside. So meaning here we have to pass some parameters. So for our parameters, we're going to pass in a string name, then we're going to pass in string C, and we're going to pass in int age. So age, I actually forgot to show you something, but no, let me do this and I'll show you. So if our still the function of the main purpose of a constructor remains the same, is to initialize data. So but then so with a default constructor, we initialize our data to some default values, but then with a parameterized constructor, we pass in our the values which we want to initialize our data to when we create our object. So here we're gonna set name to n, and we're gonna set course, we're gonna set it to C, then we're gonna set age to A. So then here at the moment we're creating our object. At the moment our default constructor is being called. So if we want our constructor with parameters to be called, what do? We open our round brackets, then we pass in the parameters. So remember the main purpose of a constructor is to initialize data. So, and a different way to initialize data, either with a default constructor or either with a parameterized constructor. So with a parameterized constructor, we pass the values which we want to initialize our data to when we create our object. So our default constructor passes have to accept the name, So we can call this maybe Dikhale. Then for the course, let's say this guy is doing BSc and was teaching Bachelor of Education. Bachelor of Education. Yeah, let me just leave it like that. Then let's say this student is 25. So yeah, this is us calling the constructor with parameters. I don't know how many times I'm gonna repeat this, but don't. Yeah. So uh, this is us calling the constructor with parameters. So as you can see, this thing align. So we pass in a name and cost followed by an age. So same thing as we're doing here. So this is us calling a parameterized constructor to initialize our data. So now if we compile this, you're gonna see that our data is going to be initialized to those values we passed. So yeah, this is just the point of a constructor to initialize data. So any question on so remember, so let's actually create two student. So student, let's say this is student two. So here, so student one, we're using parameterized constructs, parama, para, parameterized constructor. Then for this student, we're calling the default constructor. So yeah, so let's say student two dot display. So yeah, so this is how we call the parameterized constructor. Then you pass in the parameters. Then this is how we call the default constructor. You don't include the brackets, the round brackets. So this is how we do it. So if I display this, if I run this, so student one, his details are going to be initialized to whatever we passed here. Then for student two, we're using a default constructor. So his data is going to be initialized to the default values here. So now let's compile. But as you can see, student two, the data of student two is being initialized to the data we passed on our parameters constructor. And for student, oh, this is student one. And for student two, the data has been initialized to the default values. So yeah, that's default constructor and parameterized constructor. Any question on parameterized constructor? Oh, all right. Now let's move on to a copy constructor. Whew, this one is, but it's easy. Let me not say it's hard. So with a copy constructor, so I agree you have noticed that. So with a copy constructor, still the main purpose is to initialize our data to something. So with a copy constructor, uh, we're going to pass in an existing object and use that object's data. We're going to initialize that object's data, that existing object's data, and initialize it to the data, to the current class. Which I don't know how to explain this. So let me explain it in code. So what we're gonna do here is that we're going to pass an existing object. So of type student. So this is our student. We're going to pass a student here. So normally we say original student. I don't know why. So don't have to. But normally we say original student. So now I remember so we have student one, for example, and we have student two. Student one has its own data. has a name, has its own name, has its own course, has its own age. Student two has its own name, its own course, own age. So now we want to create student three. So we want to create student three, but then so we want to create student three, but then we want to create him using a copy constructor. So what a copy constructor does is that we pass in an existing object. So we pass in an existing object, then we're going to copy the data of that existing student and initialize it to our student. I don't know if that's clear. So basically, let's say we want to create student three. So using a copy constructor. So what we're going to do, we're going to pass it, and we want student three to be exactly the same as, oh no, let's use student one. So let's say we want student three to be exactly the same as student one. So we're going to pass an existing object, which is student one. Then we're going to initialize the data of student three to the data of our student one. So like we're actually copying. So we're copying the data of student one into student three. So copying the data of an existing object to our current object. So what we're going to do is just going to say name is equals to, so we want to copy the name of our existing object. So just going to say original student dot name. Then course is equals to original student dot course. Course, then age is equals to original student dot age. So yeah, what the copy constructor does is that we get an existing an object that is already existing, then we copy that object's data to our class. So this is how we use what's this, a copy constructor. So here we're going to pass an existing object. So for this example, we're just gonna pass student one. So this is a copy constructor. This is a copy constructor. So let's display the information of student three. So the details of student three are going to be, so the data of student three is going to be initialized to the data of student one. So basically student one and student three basically have the same data. This is what a copy constructor does. So now if we compile and run our code, this is student one, Dikhali, Bachelor of Education, 25, student two, student orientation, blah, blah, blah. Then as you can see, student three, we copy the data of student one to student three. So basically with a copy constructor, like you can even hear the name, it says copy constructor. So we copied the data of an existing object and initialized our class with that data from an existing object. Any question? Any question? Any question? Copy. Am I explaining in an understandable way? Any question? Okay. So now let's go to our final constructor. So this is the, oh, before I go to the deconstructor, so I wanted to show you something. So so I think you notice that here is I use N, C, and A. So let's say here instead of N I use name, then here instead of course I just, instead of C I used course, and here I used age. Then in here I said name is equals to name. So with this name I'm referring to this one. I'm saying name is equals to this name I'm passing. Then let me say course is equals to course, and age is equals to age. So let's say I our the name of our parameters are the same as the name of our data. So, so let me ask this question. What do you think is going to happen? What do you think is going to happen here? Which is which? What do you think is going to happen? Type in the chat or open your mic and tell me what you think what's going to happen if I do this. How will C++ know which name is which name, which one is the parameter, which one is the data? Like we can what do you think is gonna happen? Don't have an answer. Or you're typing. So what's gonna happen? I forgot the name of the error, and they're going to ask you this in the test. What's gonna happen here? So here we have a case where the name of our parameter is the same as our data. So there's going to be confusion. There's going to be a confusion here. So how does the programmer know which name is which one? So in this case, if we do it like this, the compiler is going to use the parameter one. So since this parameter has the same name as the data, so the compiler is just going to use this one. So this is what we call this error. This is what we call. I actually forgot the name of this error, but they're going to ask you what's going to happen here. So what's going to happen is that so here you're literally setting name onto itself. Like you're saying name is equals to name on itself. So this name you're going so this parameter, this variable from the parameter, this is what's going to be used. So this is the same as this one. So this is not going to be this variable here. So this is called something. So but then so if I try to run this, you're going to so you see for student one, so for student one, I mean, yeah, for student one, we passed the Bachelor of Education and 25. But then when we come here, they're not set, so those things we passed. That is because we literally set this thing onto itself. So we literally said name is equals to name. So how do we fix it? So if it happens that uh, the name of the parameters are the same as the name as the name of our data. So what we use this keyword. So we use this keyword. So what this what this does is that this is going to tell the compiler that I'm talking about the name for my data. I'm talking about this name, and this one is just going to be same as the one from the parameter. So we fix it using this. So yeah. So even here, if this was name, so we're gonna say name is equals to name. Then to fix it, we're going to say this dot name. So now if we run this code, so let's check if this will run. Okay, there's an error. Oh, we actually have to use instead of the dot, we have to use a pointer. I don't know why yet. And we have to use this. So instead of the dots, we have to use this thing. So let's run that and see what the details for student one will be. As you can see, student one will have will be initialized to the information we passed. And yeah, so I just wanted to tell you about that. So any question on this before we move on to the deconstruct? Are you sleeping? Any question? Uh, so for the deconstructor, so the deconstructor is used to is actually like it's actually like remember how when we created pointers, I get it, firstly we had to allocate memory. Then before we terminate our program, we had to deallocate memory. We have to delete the memory we just created. So same as the deconstructor. So a deconstructor, so we we don't have to call it. It calls itself automatically before the program terminates. So what happens in a deconstructor is that if we had any pointers in our data, so we're going to delete uh, our pointers in our deconstructor. So at the moment we don't have any pointers. So our deconstructor for this example is useless. But then this is how we create a deconstructor. So we use this sign. I think this sign is called mm, I forgot the name of this sign. Mm, Delta. I think this is we say delta, then we write the name of our constructor, which is the name of our class. Then we don't pass anything. Don't pass anything. So yeah, at the moment there's nothing we can do. So if we had a pointer in our data, uh, the deconstructor is where we will delete the data. So this is where we will delete our pointers. And we remove that. So yeah, at the moment, so for our example, we're not using any pointers, but then if you had pointers if you had pointers in your data, this is you delete it in your deconstructor. So the deconstructor, we don't have to call it. The deconstructor will call itself automatically before the program terminates. You don't have to call it. So yeah. Any question on that? The deconstructor. Okay, then yeah, so this is basically everything you need to know about classes. So we did we talked about function pointers, then classes and objects, then um the member data. What did I say? Then we talk about the data member, and the data functions. Then we also talked about access specifiers, this public and private. Then we also talked about constructors, so and getters and setters. So this is all we're gonna do for today. Then in the next session, um, we're gonna be doing polymorphism. I mean composition, where we have a class inside of another class. So this is where we're going to be heading to in our next session. Any question on our today's session? Anything you didn't understand and want me to re-explain or something? Okay. If there's no question, then our session will end here and we will continue next week. Have a pleasant night.